In this video, we're going to be doing a Unit 1 MCQ for AP Physics 1. So question 1, scalars versus vectors. Which of the following is a vector quantity? So a vector quantity is something that has both magnitude and direction. So let's look at our choices and see which one matches. Well, we know speed is a measure of how fast you're going in a direction. So if we have speed, we're only measuring how large it is of a value. We're not measuring in a certain direction we are traveling this speed, so it doesn't quite have a direction. Now, what about distance? Well, when you measure distance, you're basically measuring the path that you took. How many meters, how many feet was that? That is, again, just a magnitude, and it's not including a direction. What about velocity? Well, when you have velocity, you're measuring a magnitude, how large of a speed that this is, but you're also measuring what direction that you are traveling. So this is why velocity is going to be a vector. Now, time is a scalar, again, because it has only magnitude. It's a measure of what something is, what time it is, how many hours past 2 o'clock, but it doesn't tell you the direction. So what about a car travels 10 meters east and then 5 meters to the west? What is the car's displacement? So if we have our car at this point and then we go 10 meters to the east, and we'll define our east as positive, and then the object is going to go 5 meters to the west. And we'll define our west as negative. So we want to find its total displacement. And the key term is that when you're trying to figure out what displacement is, you're looking at specifically the initial point that you started out at and the final point that you end up at. So visually, we can see that this is going to be a displacement of if we just went 5 meters this way, starting from the beginning and just going that way, and we never backed up that 5 meters. So essentially what displacement is you traveling the shortest possible distance from the starting point that you were at to the final point that you ended at. And you're finding that distance. Now, the actual path that we took is the distance that we traveled, because you could travel any amount of distances to get to the same displacement. But the displacement is just the shortest path. And we can find this mathematically with x is equal to 10, which is how much we traveled in the east direction, positive, minus how much we traveled in the east direction, or west direction, so that was 5 meters. And this gives us 5 meters, and this is a positive value, so that's how we know that we traveled to the east. Now, a runner completes 1 full lap around a circular track. What is the displacement of the runner? Well, again, displacement is equal to your final position minus your initial position. So if you run 1 lap, that means that the runner is going to end where it started at, where they began at, because the runner is going to just complete 1 full lap at the exact position that it started at. So as you run here, where this is your beginning point, you go around and then you end here. But we're measuring displacement from this point that we're at. Displacement is moving away from the place that you started from. But if you come back to the exact place that you started from, your displacement is going to be 0. So a car travels 20 meters in 4 seconds. What is the average velocity of the car? So if they travel 20 meters in 4 seconds, our average velocity is going to be equal to our change in displacement over time. So this represents our displacement, and this represents our time. So our displacement is going to be that we moved 20 meters, and the time interval that we completed this action in was 4 seconds. So that's why our answer is going to be 5 meters per second, and we can see the units right here that we derived. So our answer is A. Now, what about for our next question? We have an object moving in the direction that is negative is slowing down. So if we're going in the negative direction, we are currently slowing down. And this is our negative direction, therefore this has to be our positive direction. So if you have a negative v and you're also going to be slowing down, that means that the term slowing down indicates that you're going to have an acceleration that opposes velocity. So that means if your velocity is currently in this negative direction, that means that you're going to actually have an acceleration that is in this positive direction. And because they're opposing each other, that's going to make our net smaller, which is why it's currently decreasing its value of speed. So that's why we're going to say A, positive. So acceleration is opposing. Now, our acceleration is defined as what? Well, our acceleration is defined as our change in velocity over time. And our velocity, this is going to include both our speed and also our direction. So our answer is going to be B. It's a change in velocity because it does include speed and it does include direction, but it's not just speed. It also includes your time. So it's change in velocity over time. But it's not just speed because it has direction as well, not just position, because position is going to be, the change in position over time is equal to your velocity. And distance over time, that is your, right here, your definition of velocity. This one, I mean, because position is different from distance. Now, which graph represents constant velocity? If you have constant velocity, we have to look at what each of these look like. So if we have x versus t, and it's a curve, that means that for a position time graph to have a constant velocity, you're going to have a straight line, because position versus time, delta x over t, whenever we're finding the slope of something, m, that's going to be the change in our y direction versus our change in x direction. So that is going to be equal to v, because we can see that this formula v delta x over t, this is the general formula that we know is equal to our velocity. So that means that we just conveniently have, like, this is the definition of our velocity. So that slope, if it's constant, that means that's going to equal to our v. Now, how do we also have a constant velocity if we have a v versus t graph? If we have a constant velocity, constant on a velocity versus time graph just means that your velocity has to be equal to a one value. It can't be changing. So it would just be a horizontal line. Now let's see. This is going to be both B and C. We're going to have a straight line position time graph, which means like a straight upward line, and also a horizontal velocity time graph. Now, the slope of a position versus time graph represents which of the following? Well, if you have position versus time, just like we saw, that slope is going to be the change in y over the change in x, which is going to be on our x-axis, we have our t, so that is going to be delta t. And on our y-axis, we have our delta x, which is going to be our change in x. And that is our velocity formula, so that is going to be B. Now, the area under a velocity time graph represents which of the following? Well, let's look at velocity versus time. Well, on the y-axis, what we have is delta v. And then on the x-axis, we have delta t. And we can see that this is our formula for acceleration. So that slope is actually going to be our acceleration. But what we want here is the area under the velocity time graph. Well, we can make an area right here. Let's make this our area. Let's make this let's make this 1. And make this 2. This is our time in seconds. And let's make this 1 and 2. Our velocity being measured in meters per second. Now, how are we going to find what this area under the curve is? Well, we have to find the area by, or let's just make this a rectangle for now, to keep things simple. So to find the area of a rectangle, that's going to be your base times your height. In this scenario, our base is going to be our time, and our height is going to be our velocity. So the units for those are going to be time is measured in seconds, and our velocity is measured in meters per second. So this is going to be equal to m, because those seconds will cancel out. And what do we know has the units of m? Well, we know that displacement has the units of m. So that area is going to be equal to displacement. So if you found the area under this curve, specifically we have a base which is equal to 2, and we have a height that's equal to 2. So the area of this curve would be 4 meters of displacement. So the slope of a velocity time graph is going to represent what? Well, we just found the slope of a velocity time graph, m is equal to delta y over delta x, and we have v and c here, so that's our delta v over t, and that is going to be our acceleration, which is option B. Now, for our next question, we have an object is dropped from rest. The acceleration of the object is going to be what? So if it's dropped from rest, the object is going to be acting under free fall motion. So everything on Earth always has to feel the presence of gravity. So what free fall motion means is that the only force in this object or on this object is going to be Fg. Even though all things on Earth have that Fg force, now this force only has exclusively the force of gravity. So we know from Newton's second law that the summation of our forces, or just our forces, are equal to mass times acceleration. So in this case, we're going to have the force of gravity, and the force of gravity is equal to the mass of the gravity times the mass times the gravity, your gravitational constant. And you have that's equal to ma. So you can see your m's will cancel out, and you see that your gravitational constant is going to be equal to the acceleration that the object is going to be receiving. And the acceleration is going to be in the downward direction since we are moving down. It's accelerating downward. So the answer is going to be B. So all objects in free fall, they're all going to accelerate downward at a gravitational constant of g regardless of mass. That's because our mass will cancel out of our equation. An object is thrown upward. At its highest point, its velocity is going to be what? Well, if your object is going upward, you have to think about what forces are going to be acting at this object at every single point in time. So as our object goes up, and our initial position here and our final position here, no matter where you are on Earth, you're always going to have that force of gravity that is acting downward. Always trying to push that object down back to Earth. But because you're throwing that object up, that means that you had to throw it up with an initial velocity, correct? So as that force of gravity acts in the opposite direction of our initial v, or that force that the object is going to be pushing that object, because those forces are opposing each other, that v is slowly going to be degrading that fg, and as it rises up, it's going to slow down. After it slows down, then at the top, that is going to be the very moment that your v is going to be equal to 0, your vy specifically, because then your object is going to start going downwards again after that. So at this very top point, it's going to be momentarily stopped. So on the way up, though, we have to remember the velocity is decreasing or decreases due to our force of gravity. So the reason why our Vy is equal to 0 at the very top point is because at this point, this is when the object changes its direction of motion. What this means is that the object goes from going upward, right? So at first the object was going up. Now the object is going to move to falling down. So because it changes direction from going up to down, now if we look at this on our graph, where we have our velocity and time, we are going to have this as our motion, and during the beginning this was a positive velocity, but then it turns to a negative velocity. So this is going to be your peak point when you cross between that positive portion of your graph to the negative portion, and that is all due to the change in direction. Now at the highest point, your acceleration is going to be what? Well, you're at your highest point, your acceleration when you are in free fall is going to be equal to g, and that is going to be in the downward direction. So no matter where you are, even if you're at the top, you still have gravity acting. So your answer is still going to be negative downward. Gravity acts at all times, so your acceleration remains downward even when your v is equal to 0. Now, a person walks toward or forward inside a train moving forward. Relative to the ground, the person's velocity is going to be what? Well, relative velocity, you're going to have v of the person, ground, is going to equal to v person, train, plus v train, ground. And since both are going to be in the forward direction, we're going to have that our v total is equal to our v train plus our v walk. So then our v total is going to be greater than our v train. So our answer is going to be C. It's greater than the train's velocity. Because we are moving in the same direction, when you move in the same direction, you're just going to add, because we defined our direction as a certain positive direction. So then none of those are going to be opposing, so you don't have to subtract them. Now, which equation correctly represents our relative velocity? Relative velocity is VAB, which is going to be the velocity of object A relative to object B. So as a formula, that's VAB is going to be equal to VA minus VB. So our relative velocity is found by subtracting observer's velocity. So this is your observer, and then this is the thing that is acting. This is your thing that is being watched. Your observer is the watcher. And then this side is your relative velocity. So that is just option A. A ball is thrown horizontally from a cliff. Which of the following is going to remain constant? So we have this, and then it's thrown horizontally. And it is going to undergo projectile motion. So in projectile motion, you're going to have in the horizontal direction a Vx, and this is going to be something that is going to stay constant and continue to propel your object to whichever direction that is horizontally launched. You're also going to have no acceleration. It's going to be equal to 0 in the horizontal direction. But in the vertical direction, you're going to have your g that is acting. Your velocity in the vertical direction is also going to be changing. It changes. Your acceleration is going to be constantly down. So here our answer is, so what's going to remain constant is both B and C. Now in projectile motion, neglecting air resistance, horizontal and vertical motions are independent of each other. This is because when we have projectile motion, we want to analyze both of these separately so that we can add and subtract them. But if we have them merged together in our velocity vector, then we are not going to be able to analyze them and add and subtract them and make them cancel out as easily. Because things will be at an angle, and if they're at an angle, you can only add vectors that are in that angle. But if we isolate them to be in vertical and horizontal direction, our math is going to become a lot easier. But if you want to get that velocity vector back, you're just going to use your Pythagorean theorem. Now, the horizontal component of velocity is going to be what? If you break into your components, you're going to have that Vx is equal to V cosine of theta, and Vy is going to be equal to V sine of theta. So your answer is going to be V cosine theta for your horizontal component. Now, that's because we're going to use the cosine of the angle that we're going to have. So theta is going to be here, and then this is going to be our Vx. We're going to have this as our adjacent side, and we're going to know our hypotenuse, so then we're going to relate that with the angle of cosine theta, which is equal to adjacent over hypotenuse. Now, the perpendicular velocity components are 3 meters per second and 4 meters per second. Our resultant vector is going to be what? Well, we know that we can use the Pythagorean theorem, so V is going to equal to the square root of 3 squared plus 4 squared, and this is going to be the square root of 9 plus 16. So this is going to give you the square root of 25, which is going to be equal to 5 meters per second. Now, a projectile is launched at 30 degrees and 60 degrees with the same speed. which of the following is going to have a greater range? Well, our range formula is going to be equal to v squared sine twice the angle that you're inputting divided by your gravitational constant g. So we can calculate this for both our angles. So if we have 30 degrees, we're going to have v squared sine twice times 30 degrees over g. And this is going to be equal to 60 degrees. Now sine 60 degrees is going to be right here. We're going to be at a point where we have 1/2 as our x-coordinate and root 3 over 2 as your y-coordinate. Now, no matter if your height is over here, that's still going to be the same height of root 3 over 2. Now, if we were to find the range of 60 degrees, we have v squared sine 2 times 60 degrees, which gives us sine of 120 degrees. On the unit circle, that's going to be negative 1/2 root 3 over 2. And that is going to be the same height as our sine 60 degrees was. So we can see that sine 60 degrees is going to be equal to sine 120 degrees. Therefore, our ranges are going to be equal.